Let's see, Roger. Oh, shoot. I don't have Roger. I don't have Roger's number. Hold on. Do I? I mean, I don't have it. Well, shoot. Well, I hate to be redundant. I hate to start. I'll be right back. Oh, no. Hey, Roger. You might be muted. If you look at the bottom there, you might have the little microphone. It might be muted. We still going? Yeah. I can't hear you, so we'll have to figure out. Sometimes we have this little issue where, let me screen share. Down here at the bottom, the little microphone. Might want to try. For some reason, it mutes people when they first come in. And if we can't get the audio to work, you can call me and we can use the phone. Uh-oh. Well, we have these little glitches every now and then. We'll just wait to see if Roger calls me or joins back. But this is his building. I was going to try to call him. Oh, here we go. Hey, Roger.
Hey, Tony. How you doing?
Pretty good. Sorry about that.
Yeah. No problem. Let me go back here a little bit.
One thing we can do is if you want to join that meeting back, we can just use the phone for the audio.
Okay.
And then that way you can see my screen.
Yeah, hold on. Let me go back in there again.
If it's okay, I'm recording too. I'm making a video. If that's okay.
Okay, I'm going back into the app. I don't know why it's not working on the mini pad or the iPad.
I don't. Yeah, it always seems to work on a PC, but for some reason I have had this trouble before on Mac. Apple products. It works better on Chrome.
Okay, you're in a meeting using the app. Press that. Open. Okay.
But if you just want to join back, we can.
Yeah.
We'll just use the.
There we go.
Yeah, now.
Let me take and turn the
you'll have to use headphones though, because we'll get feedback through your speakers or through your my sound coming out of your speakers will go back into your microphone.
Okay, how's that now? I turned the mute off.
Oh, you know what else too? Let me turn off the part of it was the phone, I think. Can you still hear me?
Yeah, I can.
Okay,
Actually,
cool. Okay. Sorry about all the little. Usually after the first meeting, it's easier because everybody's kind of used to the way the server's set up.
uh-huh.
But can you see my screen okay?
Yes, I can.
And so don't be alarmed by anything you see yet. So this is just I had about a 3-hour head start on you, so I thought I'd try to do some things to see what you thought about them. But I guess
Okay, what pitch do you have on the roof right now?
that I have 2 pitches. I got this one at 4, and this one at 6. And I was gonna.
Let's do a 6.
What's that?
Let's put the 6 on there.
Okay. The reason I did that is because you probably save $5,000 or $6,000 just by. Oops, I didn't mean to copy it. I meant to just move it. I think I moved 100 feet. 100 feet. There we go. I didn't know if you're just looking for the aesthetic of a 612 or.
No, I just wanted to shed the snow off faster.
Oh, okay. That's right. You're in Washington, aren't you?
Yes.
Okay. Well, I just wanted to offer that as a value engineering effort.
Well, the 412 is cheaper. I understand that.
Yeah. Everything about it is cheaper. The labor, the material, you're also not grabbing as much wind force. The wind forces
You got less surface area to with the lower angle.
Yeah. Your roofing is shorter, all that. So anyway, I was just thought I'd show that, and then the other thing I was going to mention too is that the other thing that would save money is stepping this porch down.
Mm-hmm.
I forgot. I didn't really remember. Is this 12 feet or how deep is the porch?
That's 12 feet. And
Okay.
then what's the height on
I got this at 10 feet to the ceiling, which is already kind of high. Well, for a typical ceiling, for a porch ceiling would be more like 8 or 9 feet. So
Yeah, but when you look at the angle at the for where that's at, what is at the what would say it, as you're sitting there right now, let's call the east end of that roof.
which would be the east? Like which way is the front?
Oh, sorry. Let's say let's flip it around, because the boxes are going to have their openings facing the other direction from where that is. So I'm not going to have any door. Well, I am going to put a sliding door a rolling door on the.
I was kind of going from this. So
Yeah.
So the doors.
The doors on the boxes are going to be facing the other direction.
This is what we would call our front elevation, right? So
Yeah.
these are going to be facing the rear.
To the rear, yes.
Okay, I'll fix that. And then let's start from step 1 here. Is this going to be on a slab?
We're gonna pour slab in the center of it. Yes.
So, well, you're going to have a foundation to support. Are you just going to try to do piers then for the?
Yeah, we're going to do the piers to set the boxes on, and then what I'm going to do is come in and pour the slab on the inside of the boxes.
Okay.
I'm going to put hydronic heating in the floor.
And then this slab will extend out to get that little addition thing. Let me get this picture closer so I can.
Yeah, unfortunately, that picture I gave you, I showed an extension on it.
Mm-hmm.
Don't worry about that extension. That's not going to go on
Okay,
there.
so the door's just going to go right there.
Yeah, that's going to be a
Okay.
20 foot by. We'll probably bring the door down um, so the height on the door is at 16 feet.
Okay. Because I guess we're at not. Let's see. Yeah, we're at 19 feet from here to there. Or
Yeah,
looks like I got a 16th off somehow. I bet I'll fix that.
yeah,
But I was going to look at this concept of this porch stepping down to kind of give it a more pleasing appeal. Plus, it would save you some money too. These posts don't have to be so long. If this roof goes all the way up here.
yeah. I understand. So one of the things, let's bring it up. If you're at, um,
Now, if
so
you just.
looking at the west side of that roof.
Are we calling this the west side?
Yeah.
Okay.
Okay. So on the lowest point on that, what is the height on that?
Well, I've got a 2 foot overhang, but if you had a 2 foot overhang, it would be 9'5" if the ground was level.
Okay, so the reason why I'm asking that is because if I bring the tractor in there, because what we're going to do is we're going to take and open up on that bottom box on that side. We'll have at least a 10-foot opening for a rolling door in there,
Okay.
and then we'll have two windows on that side, on the bottom.
Okay. So
Um,
you're concerned. You probably need 10 feet just at the or how.
so at that lowest point, I need 10 feet for the ropes on the tractor.
We can just move this up a foot.
Yeah,
And of course this is all kind of. It can be. I can put it back up here where you had it on your drawing. I was just trying to give you a little. A little bit of an aesthetic. This kind of makes it look more like a barn.
okay,
That.
that's fine.
But I mean, it's up to you. If you say no, I don't like that. Just put it back up here.
No, because if we do that, then it allows me to put some windows up, some smaller windows up in that top section.
I like clear story top windows. Yeah,
Huh?
and these can be rafters too. I've got it. It was quick and easy to draw the trusses because I have an extension for that. But we can do it as rafters too.
Okay.
They don't have to be trusses.
Yeah, we're not looking at well, at a 6x12, it's not gonna, it shouldn't be carrying too much weight.
Oh no, and it's this. You could use probably 2x8s at 16 inches on center.
Okay.
For. But so I guess the important thing is though, what is it? What is it from? Now, will this be? What will? This won't be a slab under here, so you'll just have, or will it?
It'll be a gravel base, because
So
what
you'll
we're going
have.
to do is I'm going to take and put a part of the chicken coop will go in there. It'll have a run outside of it, so that, and then the rabbit hutches will be under there. But I'll also have some parking in there, so I'll either park the tractor under there in fair weather, or the truck under there under fair weather. But let's see, if we put,
That'd be 10'6" if I had. If we just went from the bottom of the beam, it just occurred to me too. We need to measure. Let's see what it would be. Is how much lower the. And I'm just comparing the soffit to the beam.
Yeah.
So they're about the same. So as long as I get the roof up high enough,
yeah,
the beam will be up.
yeah, I'd like to have at the lowest level. I want, at least 10 feet from the lowest level of that roof line.
Okay, so we've got close to 10'6" now, and then let's see.
That's good.
What would we have up here? We'd have about. Now, one thing, I do have a 412 pitch on this roof. Do you want me to change it to a 612? Let's see.
We do that.
I think I can change this with this. That's why I'm using this truss thing. I can
Yeah.
change it really easy. I'll just go in here and say update. You see though? See what it does?
Yeah.
it kind of wastes, uses up your wall space when you do that. But
Well, if we go 412, just
are
what do
you
you think
worried?
about aesthetics with a 412 and a 612 though? Changing the pitch on one compared to
Well,
the
that's
other.
that's actually pretty common, like on farmhouses, to see a really steep pitch on the house, and then the porch roof is flatter.
Okay.
Have you ever seen that where?
Yeah, that's well, let's do that then. We'll do a 412 on the on that roof because that'll allow me to put some
Yeah, like
light
so
or some.
between the channel and the
What are
roof
we
is
looking
about
at
three
there?
foot three. So you could
Three
probably,
foot three.
yeah, 3 foot. You could get some 30-inch windows in there. 30-inch tall probably,
Okay.
or even
Let's
like 2 foot tall by 4 foot wide or whatever. Um, so I need to.
Yeah, because that'll allow me to get some light in there
I
too
think I actually
from
had
that
some
side.
footings already drawn, but I erased them because I thought,
I
oh,
was
there they
doing the
are.
slab.
Yeah, I thought for some reason it was going to be on. But what I'll do is I'm going to change this to. Let's see. I know what I
Now you
did.
got a
Let me
you
just.
got a number of footings in there.
I know I'm going to delete. I drew this slab, and it, right before you came in, but I had these footings. Yeah, and this footing I had from another project where we.
Uh,
And
so do
it,
we need that many footings or pier points?
well, this kind of goes back. I'm kind of getting ahead of myself a little bit here. Let me turn off the roof for a second.
Okay.
I know I like talking about the aesthetics first, but
Okay.
really the structural parts. um, so what I'm trying to do is set up here a system. What happened to my clips here? Um, you said this was going to have to be. Um, Now I'm wondering. Hold on. Let me turn all my layers on for a second. I think I accidentally. Oh, I see. They're probably in the roof. Oh, cheating.
Okay. So I see you've got posts mounted on the outside of the boxes.
Yeah, let me. I've accidentally deleted my clips. I was trying to clean up the layers earlier, and I don't see any layers turned off. Let me. I'm going to undo some things here and see if I
Okay.
can see what I did. Oh boy, this is going all the way back. What's bugging me is I had fixed these posts before, like before much of anything, and I had the. Well, darn. Let me turn the roof off. That was a boo boo. Man, I hate that. Anyway, I had these. Let's see what size these. Okay, so sorry about that. I'll fix all that. What?
Okay.
Now I wonder if I can go back. Oh well, I'm just wasting time doing that. Okay, so what we're trying to do, you're going to have a structural engineer review this, right?
Actually, no. I don't have to have a structural engineer review this.
Oh, I thought that's what we talked about on the phone.
No. So I only have to have the roof has to be stamped. So originally, I thought I had to have the whole thing stamped,
Yeah.
but they came back and told me I only have to have the roof stamped.
I'm really disappointed with my clips because I had a 3-hour head start and I wasted it this morning. You know what I'm going to do? I'm going to hold on. Just give me 1 second here. I'm going to save
Okay.
this as, I might be able to play a trick on this thing. So just as temp. Then I'm going to open the one already. Open this one, and I'm gonna pray to Jesus that. That's even worse than I thought.
Well, actually,
This is
that doesn't have your post in it.
well, but
And
yeah. What I need to do now is I'm going to go. I'm going to open up. I'm going to look for a backup file now. Hold on, just 1 second. And if this doesn't work, then I'll know. Come on, Jesus. You can help me on this one. Help me out on this one. Dang, that's an old job. That's a bad backup file. That's Rex's. That's Rex's job. All right. So, all right, let's just go back to temp. All right. So, and then I just wanted to get that out of my system. And then we'll turn the roof off for a second. Okay. So, what I'm dealing with here is issues. Okay. The issue is that even though you don't have to get this thing stamped, I gotta exercise some professional quality, some professional responsibility here, right?
understood.
So what really is needed on this thing is something to tie all this together, okay? Because I mean, you don't want this thing falling down either, right?
Well, no, that's correct.
So the best thing to do would be to take some steel columns and run them up, from the top down, and then you can clip. Then you would. And I see I had these nice clips made, and it's really making me mad now. But hold on, let me go to one other job, and I think I have some just so I can show you what I'm talking about. What is that? What job is that? L-shaped container. I guess I might as well save it. What the heck? I lost my clips, man. I'm getting ready to get them back though right now.
Okay.
Front. This is a little L-shaped. I don't know if you've seen this video, but see these clips right here? Let me turn this. Let me turn this style so I can see better.
So what size are these posts?
These in this job were 6x6 treated, but yeah, I'm thinking yours could be 4-inch steel, and the reason I'm saying that is because they're 20 feet tall. You're not gonna have a no.
Do I really need to take and put that many posts up though? If I put a post in the center, that gives me a 20-foot span. If we're attached to clips, the main loading point is on the corners, right?
Not when you put a big roof like this on there, and that's one reason why I was trying to get you to minimize the roof, because you went from probably 1,250 pounds per linear foot to 2,000 pounds dead load, and you can't put any of that load on this little 2-inch, channel on the shipping container. So I wish. See, I was now I'm a little. Let me turn it. This wall sheeting's bugging me. Oops. Because I mean. Okay.
So if I do a 4-inch square post,
we're
gonna have to. Do we have to do them on the outside corner?
Here's the thing. Okay, so okay, you could get by with them on the outside corners. True, right? Because that shipping container has a corner.
Right.
a structural corner to it. You're right. That's what holds all the weight. If you did one in the middle, the problem is you're asking this beam to span 20 feet, and it gets bigger. So when you change, and it might be cheaper to make the beam bigger, and if you wanted to take out the two columns. The thing is, I can't offer any kind of warranty. I can't personally offer any kind of guarantee.
I understand, Tony. I'm just asking you. I'm just asking you the question.
I'm just going to tell you how I've built things over. I've been doing this for 40 years, okay, and I know how I've built things that are strong.
Okay.
And so I have to go on record saying that I think that they should be on 10-foot centers. But if you want me to put one in the middle, that I will. You just have to realize that you're going to have a 20-foot span on this, these LVLs.
Okay, let's do it with the 3. We'll leave the corners alone.
Okay.
We'll put, and we don't need to put 3 on the inside.
No. Your roof is gonna bear on the outside, that outside beam, just like if it was a clear story. See, your trusses aren't even going to touch the containers.
Okay, so we're gonna need 6
20-foot, 4-inch, 3/16 wall thickness.
Okay.
4-inch steel columns.
Okay.
Now the thing about it is, you're not going to have any worries, okay? Because what you're going to do is you're going to clip it right here too. This is what makes me mad. I lost my clips. I had these on here already, where they're basically these.
Are we welding them or bolting them?
Well, you can bolt them if you want to, or weld them. You can bolt them to the LVL easy enough. But
what is this? And what is this? You call it the LDL. What is that? Is that
it's LVL? It's laminated veneer lumber. It's
okay.
I had these bolted because we were using wood posts because they were only 10 feet tall, but yours are 20 feet tall.
Right.
And it would be a mess if you tried to use wood posts. You can try it, but the only thing about the wood post is you're going to have to use treated, right? Because it's going to be exposed to the weather.
Right.
And the treated post is, if it's a 4x4, I guess you could use a 6x6. But getting them 20 feet long is going to be hard. But, it's going to be wanky after a few years. But, again, I'm just telling you the best way to do it. I can't make you do it anyway.
No. Whatever you put on the sheets, that's how I have to build it. So I'm just asking you the questions because I'm not a designer or an architect. So.
Well, you see, you don't want a designer or an architect on this, okay? What you want is somebody like me who's built things. That's
why I'm asking you the question.
Yeah. But an architect would just, draw whatever, and then he would say, you know what he would do on his cover sheet? He would put structural by others. That means he is totally off the hook for any kind of failures. And it would be just a pretty picture.
Yeah.
There wouldn't be any details at all. So what I'm trying to do is detail this thing for you, so it's not going to fall over.
That's why I've got you doing this.
It's not going to fall over with a 2.5, on the Richter scale earthquake in Washington. How often do y'all have earthquakes up there?
Well, I'm sitting on a granite mountain, so it's I don't think I'm going to shake too much. So.
Well, even in Tennessee, you ought to go look at the number. We have like 2.0, 1.5. They're like daily occurrences here. We're near the San Andreas Fault, right? So, anyway, we have little tremors all the time. So, but the thing about it is, this is like, these are like Legos wanting to fall over. So you gotta stiffen them up. And what this is going to do, see, is what really makes me mad. I had these clips. I'll just be honest with you. I had these clips perfect, and I went and I don't know how I deleted them. Sometimes you just don't. You just don't think.
You'll find the other picture some other place.
No, see, I had to alter these clips because, as a matter of fact, I'm gonna cut them and then paste them in my. At least I was smart enough to make this post a component. See, is if I get one of these posts right, they'll all be right. So
let me ask you this, Tony. So we got a post in the middle, and the two posts on the either side of it. Now you recommend a 10-foot centers.
That unless you want to have a big honking beam up here that can, you see that's the value engineering part of this.
Okay.
You say, okay, I'll take out 2 posts. That's $600 a piece probably. I don't know how much your steel is going to be up there. Is that worth? Well, let's see. You got 40 feet, and they're about $10 a foot. So that's $400. So that's $800 for this beam right here, right? So if you want, and there's probably not that much different. What you want to do is call your local supplier and find out like what a
laminated
20 footer you'd have to have probably a 16-inch. 2 16-inch LVLs right here, okay?
Okay.
And those are probably going to be, say, $12 a foot, okay? Versus 2 of them at 9. I've got them at 9 1/4. Because I know they'll span 10 feet, right? So I already kind of know what'll span. So.
So I need 2 of those LDLs.
Yeah, that's how you. Yeah. That's what we do, because you need, part of this is the bearing. You need that much bearing for your trusses to sit on.
Okay.
You can't they're only 1 3/4 wide, and you need a minimum of. I ain't gonna tell you, because then you'll start trying to. You got to have at least 2.5 inch. I think 2.5 inches for your trusses to bear on. See.
Okay.
I can get down there. So they're sitting on that, right? And you can't have some little skinny ledge because there's nothing to attach to.
Oh, I understand.
Yeah. So, you could. What I'm trying to do, it's you see, I got a whole system going here though. You see, I want to run these LVLs around because I want to be able to have some continuity with my dimensions. I want to be able to build this beam system at 38 by 40 feet. Okay. That's going to be the only thing you have to tie the top of these containers together.
Okay. That's fine.
So if you cut this beam, if you can get them 38 feet long, literally you can actually get them 40 feet long too. So if I don't know how well your site is, how easy it is to get a big truck there, but if you can get a big enough truck there, you can have these. You can literally cut one beam 38 and one 40 minus 3.5 or whatever. What I do on the corners is I lap them like this. So you're, nailing, screwing, whatever into this one, into that one. You see, that's a really good joint right there for LVLs.
Okay.
So, anyway.
Well, let's figger that into the. Let's go ahead and do that, and leave.
What that's going to do is tie. You see, there's nothing. The trusses are going to tie it, but you really need something that keeps this LVL kind of standing upright. So on the end, this LVL is going to keep the beam upright. And then these posts are going to be clipped. See, had them. You gotta clip the thing to the the LVL, and then what in the world? Today is not a good CAD day, I can tell you that. Then they would be. You really need them clipped to to the
box
container. Yeah.
Okay.
So, and then down here there would be a clip going over into that channel.
Okay.
Now you could probably clip it on one side to the containers. You know, I think on this beam you need a clip on both sides.
That's fine.
I don't know what that is. Oh, that's a loose bracket. So, now what we can do is if you need to put a 10-foot door, we can make sure these are spread out far enough. You know what I mean? We can move them over a foot either way, and it's not gonna hurt anything.
Yeah.
Because you want to be able to put a 10-foot door on one of these.
Yes.
You're gonna put those openings in the containers yourself?
Yes.
That's good.
So and that's the other thing on when you do those, can you spec out what metal I need for that?
Yeah. And that's kind of easy. That's the easy part, thankfully. Because see now you don't have any load on anything. Like you could practically cut a hole in the side of this container, and you wouldn't even need a header. You see, because you don't.
So yeah, what I figured on doing was taking in whatever I cut in there, and then support it on, for the big openings. I'm going to support the header with columns on either side, which are welded in, and they're welded to the bottom, and then they're welded to the top of the header. So that basically keeps the container wall integrity for the material I move out. I just need to know, how much or what size material I should use for that, and also for the windows, what size material I should. Now I could do the windows using angle iron. I just need to know, what gauge or what size I need for that.
Yeah. See, when you weld these clips on here, right here to these posts.
Yeah.
And that channel's already structural, right? And what you're doing here is we're tying the containers together. Because down here you're going to have another clip that ties this. So you can imagine this steel column is a binding, a binder to bind these two containers together and tie it to the ground, because it's going to be bolted into the concrete. And get rid of this. Get rid of this slab because it's not there. And so there's no. What I'm trying to say is you can just cut a hole in this sheet metal, and all you need is metal to attach the door to. You won't need a header per se, because here's your header up here.
Okay.
And that's kind of the beauty of taking the roof load and transferring it to these columns and the corners, and taking it all the way down to the ground. See, because the thing that's going to happen is the building inspector is going to say, well, I didn't really think about this. I want you to tell me what how much that channel can carry, and that's where you'd have to get a structural engineer involved.
If you show him right now, the poster, the steel poster, going to carry the load.
Yeah, if you show him this, and it'll be on the drawing, right? There'll be a drawing showing this like that or whatever, right? So he's going to say, that's no big deal. I see that all the time. And that's what we're trying to do, is get past this sort of mental block on the shipping containers.
Okay.
Because they literally aren't designed to carry a load on the roof at all.
So put your shed roof on there again. Okay. So are we attaching to those posts for the sheds as well?
I'll figure out how to. We want to just use your rafters here, right?
Yeah, we could just do that.
Yeah. So what I'll do is I'll put a band going across there, and it'll be bolted to those posts. That's the only reason why it would be nice to have one on the end, but I can work it out. We can work that out, and then the rafter will just go from there down to the beam, which I deleted. So, no big deal. Oh, and I got to get rid of this. I want to get rid of this 412 pitch roof right now. I went all the way back to where I was like at 9 o'clock this morning. Let's see, I think I went 50 feet or. Oops.
Did you say 100?
Well, see, that was the second time. What is that? 60 feet. You see, I had already done this. Trust me, I goofed up pretty good. I had a lot done. I had the beam. I don't know if you remember this. I had the beam for the porch and all these posts done, and I have no idea what happened to my clips. Sometimes I hate learning those lessons like that because they're painful. I'll remember next time, though. I can tell you that.
So our trusses are how many on center?
24 inches.
24 inches on center?
Uh-huh.
Okay, so we're going to have 19 trusses and 2 end pieces. Or 2 end trusses and 19. Okay.
Let me turn off the, let's see, let me go to my roof. Let me turn off the cladding. Are you going to have a metal roof?
Yes.
Are you going to have decking or purlins?
I want to put deck down.
I think that's a good idea.
Let me ask you this. Can I put the high density foam down and then put the deck on top of that, screw that through the foam to the trusses, and then because here's what I'm thinking is what I'm concerned about is condensation. So for the roof and for the containers, what I was going to do is put high density foam, wood, the CDX, and then put that double bubble on top of the CDX with the metal on top of that.
Are you going to try to condition the containers?
Condition.
Like heat or air? Like heating?
We will have heat. So the slab that I'm pouring in the middle is going to have CDX, not CDX, hydronic heating.
Yeah.
And then inside the outer walls of the containers are all going to be insulated on the inside.
Why don't you just put insulation in the joist cavity? I mean, why would you want to put yourself through the expense of insulating the roof when you can just insulate the ceiling?
Okay.
The reason I'm saying that is because it's really not a good idea. Normally, when you see, let me turn this soffit off. Normally, when you see the insulation on the roof, they normally put it on top. It's really a big deal because they're normally decking it first and then putting the insulation down with sleepers between it, and then they do another layer of decking. And to me, it's sort of an overkill, but maybe that's just the way y'all do it up northwest. I've never seen them put the high density foam straight to the trusses.
Okay.
It's not very.
Well, the other way to do it is for me to buy SIPs.
Yeah. If you're going to do SIPs, we can change this from a truss system to just a beam that ran along here, and they would just go from here to there because they're sitting. You can get SIPs this long.
Yeah, I don't know what's more cost effective. Is it more cost effective to do a truss?
That's only 23 feet. You can get up to 24. You can get up to 24-foot long SIPs. Sorry, I didn't mean to interrupt you there.
No. So, looking at that, what's more cost effective, do you think, Tony?
Honestly, the way OSB prices are right now, you might be able to get a good deal from a SIP company because they've probably got a huge inventory of it that they keep. Whereas if you go just buy it from Home Depot, you're going to be paying. What I'm saying is if you tried to create a SIP here yourself by putting down OSB and then insulation in OSB, it would definitely be cheaper to just get SIPs because you can eliminate the trusses.
Okay.
What we would do is we'd come up with a beam that ran down the middle, and then you would have SIPs just from there to here.
The SIPs are strong enough to support the.
Oh yeah, I've done them. I've done them 30 feet long before. I mean, yeah, they're made because see, you can get them 4 or 8 feet wide, right? And then they'll have a spline in them that acts kind of as a rafter, but the panel itself has structural qualities.
Oh, I didn't realize that. I thought
Oh
you
yeah,
had that.
you get the 8.5. Is it 8.25 or 8.5 inch panels, and they'll span as long as they can make them.
Wow.
Oh
I
yeah,
didn't know that.
yeah. And see that if you're going to insulate that, if that would be cheaper, I'm pretty sure. It would be easy to price this too. You could just tell them, I need panels for, what's it going to cost me for 44 feet by 24 feet. That would be close enough. What you would do, we would make the roof work with whatever panels you can get, like 23.5. If you could get 24 foot or 20 foot or whatever they are, 22 foot, we would just make them work. I've done that before on houses where the panel company says, hey, I got 20 of these panels sitting out here that are 22 feet long. I'll sell them to you for X, and it's like sold.
Okay. So I'll need to find some SIP companies and ask them what the kind of prices that we look at. So let's look at that as an option. Go ahead and maybe set that roof system. Design it with the truss system for right now, and what we'll do is we'll put CDX down, and then we'll put the bubble, and then we'll put the metal on top of that, and then I'll insulate inside, and then I'll look at and then come up with another option to the side with the SIP panels, and I'll look at the cost to do that.
And the other thing to look at too is to look at this product. What is it called? Drip stop or whatever that they put on the bottom. What's it called? Drip stop.
I've just seen it. I just seen it recently.
It's
a coating. It's a coating that they put on the bottom,
and it keeps it from condensating. So, but that doesn't obviously give you any insulation value. It just keeps it from. I don't know. I've never priced it before, to be honest with you.
Yeah.
I've never had to. Because see, in the South, we insulate we mainly try to keep the envelope as low. Like we would never insulate. Well, I wouldn't say we never. If we were using SIPs, we would, but we wouldn't have what they consider a warm roof, where your insulation their envelope is up here. We keep our envelope down here.
Well, if I took and I did the insulation what I was looking at is, let's say if I insulated the top of the boxes and the roof across the boxes, because what I'm going to do is I'm going to sheet that cross section across between the boxes, so that airspace up above, and then I'll have a potbelly stove in there to heat as well. So. Or some type of a wood burning stove in there to keep additional heat. But there's going to be other heat generation, because on that east side of this, as we're looking at it, I'm going to be putting evacuated solar tubes, and then I'll have a big heated reservoir in one of the boxes that I'll be running the hydronic heating off of.
Cause see, if you were to just insulate this ceiling, the heat is going to be, the temperature in the boxes is going to be staying the same. See, that's what you're trying to do. You're trying to keep the temperature the same in the box as outside the box. You
Okay.
wouldn't have to put any insulation on immediately on top of the container if you insulated this ceiling right here,
Okay.
right? Because that's your envelope. As long as you get that ceiling and then the walls,
Okay. So yeah. Okay, that makes sense.
the outer walls. Now, if you're going to insulate, well, it gets too complicated to. On one story container buildings, you can build a wall on the inside that supports the roof, and because it's going down, it's going from that channel to that channel. It's going from
Mm-hmm.
that tube to that structural channel. But in this case, you wouldn't be able to do that because you got this gap between
Yeah.
the. I just think that the main thing you're trying to do, besides carry the roof load, is keep these boxes from hinging. You got a
Mm-hmm.
hinge point right here,
Right.
and so by strapping these columns to the both containers at the top and bottom, now you've got a really rigid connection.
Okay.
You know,
That makes sense.
but I don't know how you're going to insulate this outer wall.
So what I plan to do with the outer wall is they make a bubble wrap that I can lay right up against the wall, and then I'm going to come in with my framing and frame the walls that will hold that wrap in place, and then I'm going to come in. Now that's going to, and then I'm going to put 2 inch of that foam board in between the framing, and then I'm going to put CDX over the top of that. So I'll have the vapor barrier and insulation of the double bubble wrap on the inside. Framing holds that in place, and then 2 inch foam board in between the framing, and then CDX on top of that will give me enough insulation inside of the box, I think, to keep the boxes warm on those outside walls.
The weird part's going to be these doors. They're hard to insulate, but
What I made what so on those top doors, what I'll probably end up doing, and I've talked to somebody about it, is those doors you could take them off and sell them, and I may just come in and put in a some metal framing, and then just come back in with sheet metal.
yeah, that's what I was going to suggest. Actually, removing the doors.
If I remove the doors, I could sell those, and actually they give you some pretty good money for them because they get damaged all the time.
Yeah,
Um,
yeah, and that's one of the most expensive parts of the container.
right. So, and I've got the double door containers like this. So, and they're the double mechanisms on them. I like the newer. My 20-footer's got a single on each door, which makes it easier to deal with opening and closing. But these containers have the double bars on each door.
Kind of like this, how this is shown.
Yeah, just like that.
Yeah.
But they're new containers, so they're the one trippers, so they're really good condition. And then so let's see. So let me give you some more detail here for the boxes. Okay, so for that bottom box on the west side.
Well, let me do this. Let me turn them. Let me see. Let me turn them around.
Okay.
As a matter of fact, let me turn everything. Let's say I don't need to do that. I was going to just make a group out of them. And then I can, let's see, if I knew where the exact center was, might be worth trying to and then I went this way 20 feet, and then
So what's your span in between? 22 feet, right?
yeah, because you said you wanted the overall 38 feet.
Right.
Yeah, I almost made that mistake. I almost made it 20, which is
Originally I did. If I had some more width to the property, I would.
I got lucky. I got that. I have this dash line I used to locate the containers, and I got lucky.
o- Okay, so also for that front foundation, I don't want the full strip. Can I get away with that?
Well, if you're going to have a door here, I found that you really need that.
Well, I'm going to have concrete there eventually. Do I need the footing across the whole thing?
No, the reason I had the reason I did that is because I thought you were going to have a door right away. If you're going to have the door, because you can't seal. You won't be able to seal the door unless you have a concrete.
Right, understood. So and the door, the concrete is actually going to seal. The door will seal against the concrete slab that I'm going to put in the middle. But I don't have to pour that as a footing, though, right?
No. So let's think about that for a second. What you're saying is, if you just had,
If I got a 22 by 40 foot slab in between the boxes,
let's create a separate slab here, and it'll help me. It'll help me out here. 22 feet by 40 feet, and then I'm just gonna make it 12 inches thick for now. And I know it's not that thick. I'm just gonna give it some thickness. Make a group, and then I'm gonna put it. What did I make it? Was it 22 feet?
22 feet by 40.
Yeah, that's right. Okay, for some reason I thought I made it 20 there for a second. All right, so then it's gonna go. If I can get it to move, right.
There you go.
Why is that? Oh, I didn't get the containers exactly. Aha. This is where you discover that kind of stuff. They weren't exactly. There we go. Aha. Gotcha. Oops, wrong slab. This is the one I want. I want it to be right here, and then, why is that down? This still is not. I know this is nitpicky, but I just want this. When I'm referencing this stuff, I like for it to be right. That's right on the edge, and then my slab needs to come out. That's the one I want.
There you go.
What is what in the world? Where is that? What is that edge? How many slabs do I have here? What in the? I had an old slab still in there. Where did that come from? Good Lord. Did you see that little line that was back? All right, now, good Lord. All right, now we got a 22-foot slab by 40-foot slab, and then the only thing is we need, if we do away, wrong button. If we do away with the this ribbon, this strip footing here, which we can, I'll just need to bring these out. on both sides. But I'll need to do, I'll have to have. I guess my thing is, why wouldn't you just go ahead and pour the slab? When are you going to pour that slab?
Oh, it'll get poured this summer. When I build it, it'll just go in later.
Well, I know, but if you went ahead and poured it, you could just come over another foot and turn it down a little bit, and that would be your containers could sit on it too. And then all you'd have is, because you're gonna have this messy thing where you got the slab. You don't want your slab pouring around these footings because it'll crack. Your slab will crack.
Okay.
Off at an angle. I can show you where it's going to crack right now. It's going to crack like that, and like that, and who knows where it'll stop? It won't stop. The only way you could prevent that is literally to cut a control joint. You know how we saw joints?
Yeah.
You'd have to saw them like that all the way across to keep it from cracking on every footing. But now, one thing I could do is these footings could move back because they're not. This was from an old job, and these were structural. Like I had columns sitting on these. You can see that's why I had containers, but these could be literally moved back to there. I mean, they're just. Then you'd be clipping your container down to this slab.
Okay.
I don't know what you think about that.
Okay, so.
But I still think it's kind of a waste of money to put those in.
So if I pour the slab first, let's see. Well, I could. So here's the question: You want me to put the end of the container on the slab, right?
Yeah, because it's really not load bearing, and you could turn it down a little bit. Do a little bit of a turn down there, but it could almost just be like 8 inches thick there.
Because
something.
What I was going to do,
yeah,
with the slab, is I was going to have it be even with the top of the zoom in on the.
Oh, so there's no step up.
Yeah, so there's no step up
because the floor.
If I do a cut in,
the floor is
up here.
What
I'm going to be able to do is if I cut the wall here, and the cement comes right up to that, I can drive the nose of the car into it. If I want to, kind of come in and park at an angle in there. If I open the wall up.
Well, that's going to be a lot of You'll be pouring, I guess, more gravel fill in here just to get the slab up higher.
So you got to figure I've got my gravel, and then I've got to insulate it, and because the PEX pipe is going to go into the insulation, and then I've got to put a whatever the
you don't want to insulate. You don't want to insulate above your pipes.
What's that?
You don't want to insulate above your pipes.
No.
I'm kidding.
The insulation goes down, and then the insulation I'm looking at actually has grooves cut in it.
I know. I've done those floor systems. I've done those heating systems before. Yeah. The ones I've done, the pipe snaps into the.
Yeah, that's what I'm looking at.
Yeah.
And then you attach your steel mat on top of that, and then you do your pour. But I figured that this way the height of my cement is going to be. What do you figure that structural part there on the bottom is probably about 4 to 6 inches tall?
Oh, this is a 6-inch channel. That on the container, I think it's like 6 inches.
So what I figured is when I get done with the cement, it's going to be right up to the bottom of that channel.
Yeah.
Or to the top of the.
So
channel.
You're just gonna. Well, yeah, depending on how far. I mean, I'd let these come out of the ground a little bit, just so this isn't sitting on the ground. I'd have these footings sticking up just a little bit.
Yeah, and that's kind of what I figured to do anyway. And then,
So
And then what
it'll
I'm going
be,
to,
maybe, but you could put, like you're saying, you could put 4 or 5 inches of gravel first, and then, or just 3 or 4 inches, and then by the time you got your insulation and tubing, that takes up the rest of the thickness.
right. But if I pour that first, then
Oh, good
I
Lord,
guess,
Jason's got a lot to say in the comments. One way I've seen it solves is to run the secondary beams the entire length of the container from the front post to the rear, giving the upper container something to sit on.
that
Yeah,
was
we're going to
something
work
I
on.
thought about as well, is running a beam across it, like an I-beam across that outside. So, but again, what would the cost of that I-beam be compared to doing it?
Where are you talking about the beam?
So if you ran an I-beam from north to south on the container, rather than your laminated beams, your
Up here?
LVLs.
Oh, the steel's going to be more expensive than the. It's going to be a lot more expensive than
No, I was thinking if you ran
up
that,
here.
if you ran the from north to south, so
Let's
you ran the
establish.
I-beam
Let's
across
establish
there where you have
north.
the 40 foot.
But which way is north?
Okay, you're running north to south that way,
Okay, so north is up here.
right?
Okay, all right, now I got you.
So if you ran a beam across from north to south across the 40 foot on that outside wall, would you need to put the posts there? Because it,
Yeah, I mean a steel beam can't run 40 feet without any kind of. Besides that, the steel it's a matter of value engineering because the steel beam is.
no, I'm just, like I said, Tony, I'm just asking you questions.
Well,
So,
I'm trying to tell you,
yeah, okay.
but you're first of all the steel beam is going to be more expensive, and secondly, it won't. The steel, depending on what size you use, is
Uh-huh.
probably going to have more deflection than this LVL. These LVLs are incredibly stiff,
Okay.
right? When you nail them together, bolt them together like this, okay? They have
Okay.
very little deflection at all, and
Okay.
um,
We'll do them this way.
but the thing about it is too, it's easier to work with too because you can bolt into them too with lag bolts, right?
Right.
Your posts just go right in, lag bolts. So,
Well, that
I'm,
works. That works good.
I mean, you could, but you're gonna. I know what works on these LVLs. I don't know. You're gonna have to have somebody size the steel beam. It might be a W10 by 12, or you know what I mean.
Yeah.
Who knows? What we're
Well,
trying.
like I said, I'm just asking you questions just to kind of get your ideal and different ideas.
That's roof
So,
sheeting, wall sheeting. Well, I mean, honestly, we could get if I had 20 different people, and this is nothing against Jason, okay? I'd have 20 different ways in the comments to do this, okay? So I don't know them. All I know is my experience, and
oh, people. So
yeah,
these are people that are looking at you doing this while you're talking to me.
yeah, they're on the YouTube side because I told you I was running this live. I was recording it.
Oh, okay.
Because I like to have the videos, so because I literally go back sometimes and refer to these later. I'll say, "What did he say he wanted?" And I'll go back and say, "Oh, he wanted this or that." To clarify, if you run 40-foot beam from door to rear between the upper and lower containers, it allows you to carry the lower walls and allows you to take the deflection. Yeah, what we're trying to do is we're trying to keep it simple for one thing.
Well, that's what I want to do because
Because let's see, if you run a 40-foot beam, I don't want to ignore Jason, but you gotta understand, Jason, that I'm here for this is entertainment for you. Me and Roger are trying to work this out so that because he's paying for it, and I got to stand behind it. Right, because I'm drawing it. It's going to be my name on the drawings.
there you
This
go.
allows you to remove any of the walls. Oh, you can remove. Well, that's what we have. You can. That's what I just told him earlier. Maybe you weren't here. I said you can take out the There's no once you clip that channel, that floor channel to this post, there's no weight on any of these walls. You could cut out this whole sheet, this whole side, and there would be no load on any of this. Right? And that's kind of the point. That was the point in its entirety. Is that the load is placed on this LVL beam and on these columns, and those columns go all the way down to their footings, and that's where the load is. And so anyway.
Okay, I get it.
I was trying to explain to Jason.
Okay.
I know you and I had already talked about it, and see that's why I can't get into explaining it every time somebody comes in. I'm trying to provide them a little. Jason says, "Sorry to go off on a tangent." Yeah, Jason, I go off on enough tangents as it is. It's okay. It's all right, Jason. It's just that, I mean, I know how it is. We all want to. We're all human. Humans want to engineer stuff. That's just the way we are, right?
Yep.
We all just want to figure it out. We're so inquisitive. But what I'm trying to do is combine something that'll work with something that's easy to do, right? And I know this because I've done this, right? I've literally leaned this steel column up here before and bolted it to this LVL, and nothing was going to move.
Okay, well that'll work.
Yeah.
So let's plan it like that. So I'll need to figure out what I need to do on the cement floor, or the slab in there.
Yeah. So what we're going to do is leave it only 22 feet, and then I'll have really, I guess. You could get by with one footing in the middle and one on each end and one in the middle, since this is non-load bearing.
What if I do this, Tony? If I pour the slab, as you said, but I pour the footing with the slab.
That's what I was suggesting. It would be a turn down. I have a deep.
Okay, I just misunderstood what when you say turn down. Basically, it'll be a step down from the slab. The slab will still be at the elevation I want it at, but the hole and the point where it sits at will be lower, and I'll be good that way. So I just poured the slab as part of the foundations for those points.
Yeah, I'm taking you to my details page here. I'm starting to collect different details. This is what we call a turn down slab. Now it wouldn't have to be this. This would support a house, right?
Mm-hmm.
But it might look more like this, and that's the turn down. You see?
Okay.
Like it wouldn't have to be this deep. This would be, like I said. You see, this turn down slab is supporting this entire 12-foot wall and a roof. You see, You're only trying to support the containers, so that floor slab would be turned down. When we call it a turn down, because just the edge is turned down, right? Because you got all your gravel fill, and makes your slab thinner out in the middle, right? And
okay. So, can I? Okay, so go back to your foundation. Blow that up. So, can I bring that point where the cement connects to your wall there? I can bring that portion down, right?
Well, when you say down, this would be your floor line right here.
Okay. Can I take and
you mean put a notch in it?
Yeah.
You can, but it's just a lot of labor. I think your original thought is probably better. But I'm trying to keep it simple for you, right?
Yeah.
Because trying to put that notch in there, that's like something we would do for like a brick ledge for a house, and
Mm-hmm.
it's kind of complicated to form up, and it's also labor intensive. So, I think it's, and since we don't really need that much support for the containers on that side, where's your jog? Go back to it. We'll just we'll just have we'll have our corner here. Where's my I forgot exactly where it was, but I'll fix it. And then you could have it back over here, like I had them before.
Okay.
And then one in the middle, right? One of these on each end,
Mm-hmm. And one in the middle.
and one in the middle, and then you can just pour this slab however you want to.
Okay.
Yeah. Then you don't even have to turn the slab down.
Okay. We'll do it that way.
Yeah. Yeah, then what you can do is you could actually use this channel as part of your form, right?
Right.
You could pour the concrete up in here and they could finish it to the top of the channel if you wanted to.
That's what I want to do on both sides.
Okay. So this, what we'll do is we'll show, and we don't have to have as many clips. We don't have to have that many. I'm just gonna move them up when I move up the slab. And for right now, I'm just going to put them all in a group, so I don't have to worry about. I'm going to move it up now so I don't forget. So really, we're talking about moving it up because I think the floor is pretty close to the top of that channel.
Yeah, that's where I want it to be anyway.
Like that. That's why I made that slab thicker, because I knew I was going to be messing around with it. Okay. And then we'll see that's what I want to do though. I want to set that this wall with the door in it. That's where you want your garage door, your door
Right.
sitting on that edge.
So I figure we'll have to we'll need to put a post, because a 22, I put a 20-foot door in there.
20-foot wide?
A 20-foot wide. And what I end up doing there is taking in, we'll need to mount a post on the floor that'll come up, that'll run to a header. But a post on either side, probably a foot in.
Well, yeah, what you can do, we're going to be building a wall here, right?
Well, are we looking at front or the back? We're looking at front right now.
Yeah.
Okay, so we'll have, what would that wall be? That wall will be probably a foot section on either side.
Well, that's not how we look at it. We look at it as if when we frame it, it's a continuous wall, right?
Okay.
And then we make it, I know all this is wrong. I go in and edit I think it was like, edit the wall. It was 18 feet 4, I remember. Yeah, update that. And, well, how about, oh, he wants it in inches. What is that? 18 times 12. That's 16. Let's see. 216.
Are you 18 or 19?
Well, you raised up the slab, remember?
Okay.
Let's just do it that way for now. Let's see how close I am.
Pretty close.
I forgot what the fraction was. Oh, oh. Huh. I could probably get by with saying it's 221 for now, and I'll fix it. Yeah. And then we turn that siding off because you're not going to have that. What kind of siding are you going to have on the?
We'll probably get the stuff that runs lengthwise like this, like what's on the box. I know they don't make it exactly like what's on the box, but it'll be
Right,
something
just
close
a
to
metal.
that.
Where's
Just
my?
metal siding.
We'll just put for now. I'm just going to put. Oh, oh, where's that corrugated metal? There we go. See what that looks like. Yeah, we'll just leave it like that for now. And then what we would do is, now that should be 2x6 studs. Let's see. The wall should be stud depth. Good, huh? That's weird. It was already 5.5. Okay. Bottom plates. Yes. Well, I can mess with all these. I go in and set all those details. But then what I was going to do is go and put the door in.
Yeah, put the door in as a.
See how wide? Is this 22 feet?
20 foot by.
11 feet.
Probably 20 by 16.
And then I don't have the exact door, but I can get one. I can fix it. Garage door. What is that? 240? Oh, what? How wide?
20, which is at 12 times 20.
Oh, that is 240. Yeah.
Yep, 240.
And then how tall?
Let's go 16.
Wait, that's 192, isn't it? 192?
Yeah.
Yeah. Gotta remember my inches. Update. And then, now see on this, we only need a header that'll, because we don't have any load bearings. So really we just need a header that's not going to deflect. So really probably 9 3/4 inch or 9 1/4. That's good enough. And then the door, advanced options, yes. And I'm looking for the door. Here we go. Will it have glass in it?
No.
Just be no panel. Let's see what that looks like. I can edit it. Oh, I said no panel, didn't I? Dang it. I can fix it. Wall tools. My eyes are watering. What in the world? It's hard to grab once the... Dang it. Alright. Undo works. Garage door. And all this stuff should have been saved. Well, shoot. 240 by 192 by advanced door options. Yes. I meant to say flat panel. That's what I meant to say. And so where did it go? Oh, here we go. Why is it? Oh, it's still got those ugly panels though. I wish he'd come out with just a flat panel door. Is it like a roll up door or a?
Yeah, it'll be a roll up door.
Yeah, I'll just have to. Well, I'll have to replace the door, but
okay,
that's good for now. And just so I know, I need to see if I can get him to put a roll up door in there because these garage doors look funny on these types of buildings. Well, they're solid. There you go. A solid door.
That's fine.
What I'll do, I'll take and I'll turn that solid door into a roll-up door.
Okay.
And then on the back, will it just be a solid wall?
Yeah. And then we're gonna do sheet metal on the trusses too.
Is it 221? Oh, I keep forgetting I don't have to. What in the world? Yeah, I think I just have the. Yeah, I'll just have to go in and add it to the roof if I haven't screwed that up. Yeah, good. That's good. Corrugated metal roof. Oh, yes. Corrugated metal update. And I'll have to go in and fix it to extend it down over the LVL.
And we're gonna do the same thing on the shed roof too. I'm gonna close that in.
Oh, you are?
Yeah.
So maybe it would be easier to use trusses. Well,
That's fine.
Well, let me look at that on the techniques of installing. Because we either. Yeah, I'll look at that and see what's going to be easier, the easier way to build it. And then I'll start looking at the. Oh, on the soffits, are you going to have, will they be enclosed like that?
Yes.
Okay.
Yeah. I'm trying to keep the critters out.
And I'll fix my post and beams down here now. I wonder if I got that. Let me check that height again, because I think I might have lowered it back down when I undid things.
Well, we went to 412 on that.
That's 10'7". No, I think I kept it. It must be at the right height.
Yeah.
Cause we had 3'3" right here. As a decent in between. Yeah, well, from the top of the channel down to the roof. Yeah, 3'4". Wait a minute. Why does it say more? Let me do that again. Yeah, 3'3". And so in here, you would have a ceiling too.
Yeah. I'm going to close that in. Otherwise, I'll end up with critters living up in there too.
Yeah. Ceiling, yes. And then wall. says yes. Oh. Here we go. Here we go. Gable wall cladding, yes. Yeah, we'll just show it as just corrugated metal for now. There we go. And I'll fix it. I'll make sure it's all. Are you going to use that like that tough rib? What are the panels? The
for
the like the regular wall.
Yeah.
Metal siding.
Yeah. Yes, sir.
Okay, that makes sense. And I guess we'll just have to come up with some way to cover up these gaps.
I just figured I'd get some of that. I'll get some of that steel, cut it, and tack weld it into place.
Okay. That should be easy enough along here. On that. Might be able. You know what's funny is you might be able to get a like an angle that sit on that ledge and then come out and hang down. And just like you said, tack weld it on. It wouldn't have to be any kind of heavy gauge. You could use like a 16 gauge or angle there, and just or some kind of 1/8 inch thickness or whatever you can weld.
Right.
And then let's see. I'll do the footings for these. Oh, now on the which of these bays do you think you'll do the door?
Let's put a 10 by 10. No, let's see. Yeah, I need a 10.
I'm just going to
10 by 10.
I'm just going to write myself a note here in the 10 by 10.
Yeah. And that'll be a roll-up door as well.
Let's see. Let's make it a foot so I can't. I'm just going to place that. In which bay?
Let's set it in that bay right there.
Okay.
That's fine, where you wrote it.
Why did it do that now? Good Lord. Everything just working against me today. It's weird. And then windows.
Yeah, put a window in that bay. I'm going to put a man door in that bay.
This one right here?
Yeah.
Okay.
And a window in that bay.
Over here?
Let's do that one there, yeah. And let's make that a 4x4.
Oops, let me go back and. Okay.
And let's put a 4x4 window on the other side of the roll-up door as well.
Anything on this side?
On the top box, let's put 3 4x4 windows on the top.
Just like spaced evenly?
Yeah, spaced evenly. And on the bottom box, the same thing. Did I say 4x4s? Yeah, 4x4 windows. On the bottom box, yeah, let's do the same thing.
Okay. 4x4. What is let's see. What kind of windows were you thinking?
Sliders.
You think, what were you, let's see. I don't mean to say what are you thinking. I mean, I wonder what 4x48, 48. I wonder what that looks like. I'm just going to give a box a little thickness so I can stand it up. Yeah, just for the fun of it. I've got windows. I'm just trying to make something quick here, so we can look at scale. Really is all I'm looking at. If I can get it to stand up. Okay, that's not bad. That's not a bad size. At first, I was wondering about what's going to help is the fact that they're sliders.
Yeah.
If they were like double hung windows, it would look funny, I think. But since they're sliders, they've got that sort of divided look, and
right.
4 of them will look fine.
Yeah. 4 or 3?
I'm sorry. Yeah, 3.
Yeah.
Did I put 3 over here? Oh, 4x4 window. Yeah. Okay.
Okay. So what I'm thinking. Okay. See that bottom box in the side where you got your cursor now.
Mm-hmm.
I'm going to have probably a 10-foot room, 10-foot length. That's going to be my battery and solar control room. So my solar batteries and everything are going to fit in that room.
Where are your solar panels going to go?
My solar panels are already up, and they're up. They're going to be. If you look to the box, if you flip the box back around, so we're looking at the front. Let's look at the front. Okay, my solar panels are, as we're looking at this, they're going to be to the east of. They're already mounted on post.
That's good.
East. Yeah. They're not being mounted on there. Now the evacuated thermal solar panels, those are going to be mounted on the ground to the east, just east of the lower box.
No, the reason I asked was because I realized our roof is facing the wrong way. Right? Because do you actually know where north and south is?
Yeah. So if you're looking at the box right now, just bring the face to us. It's the system. It's almost going to be north and south.
So this is the south face.
No, that's the west face. And that would be the roof. That's a south-facing roof.
Okay, so you could put if you put solar panels up here, this would be facing south.
Right.
Okay. All right. So your panels out here are facing south.
Yeah, they're facing south out there. Yeah.
Oh, okay, that's cool. No, it's kind of funny because you and I, when we first started talking about this, we were talking north and south.
I know. We kind of got
general directions. So, because what I do, if I have a site plan, I put a north arrow, just so we know where. I typically, if I don't know the cardinal directions, I usually say this is just front, right elevation, back elevation, left elevation.
Front is west, back is east.
So you want me to go ahead and call it west elevation?
Yeah, you can do that.
Okay. I like to do that if I know, so that way. And that's cool because your windows being on this side will give you some solar gain there.
Yeah. Plus you got, but what I'm thinking is maybe just putting 2 windows on the bottom box, rather than putting a window into that battery box or into the controller box. Well, you think that'll look too weird?
Where would the window be left out?
Off of the front section.
Right here?
Yeah.
No, I don't. I mean, you know, if I wish I had a wall there, I'd just go ahead and plop the windows in. But I'm gonna have to physically cut the.
Yeah.
It would be quicker for me to actually cut the windows out on the side than the way I'm gonna have to do. Because the in CAD that this crazy back and forth.
Yeah,
I didn't
understood.
mean to copy that. I meant to move it over a little bit. But I'm just going to roughly. Well, let's see. These two would come straight down then, would they? Just kind of roughly show you what it might look like. I mean, I don't think. I mean, it's one of those things. It's just part of the function of the building.
Yeah, because I'm trying to keep that area environmentally controlled as best as I could, and by putting a window in there, one that'll let sun in, which will add heat during the winter, during the summer months, and also give up heat in the winter months. And I'm gonna, if I that room's going to be really well insulated so that I can regulate the temperature in there to maintain the temperature of the batteries.
Mm-hmm. Well, I wonder, you have to vent that room somehow? Or those batteries aren't off gassing?
Yes, so I will have a fan off gas or pumping out the hydrogen while those are charging, because they will outgas hydrogen while they're doing the charge.
How many panels what kind of KW do you have on your, how many panels?
I got 7.5 kilowatts,
That's pretty good.
24 panels. It's about 3 times bigger than anything my neighbors are running. I went a little overkill with it.
Well, if you can afford the panels and the batteries, why not, right? So,
Well, I figured, I got a 30% tax break on them, so they gave me 30% back off of the total price. It cost me, including the heavy equipment, cement, poles, everything that I did, it was $37,000.
we've done several solar projects, right? But they're not really popular here in Tennessee because of all the shading. We got too many mountains and valleys and stuff. But I've always tried. There was a couple of people I tried to keep them. I tried to let me put them on pole mounted panels out in there. They had a field even. They had a farm, a field right by their house, and I was like, let me put them out there. I can face them exactly south, and they'll be tilted just perfect because their roof was facing the wrong way, and they just wanted them on the roof no matter what. They had to have them on the roof, and I thought, man, this is frustrating.
No, I put mine on post, and eventually, I thought about putting a tracking system on them, but I have a straight shot at the south, and because I'm building on the knoll of a mountain, and I got big wide open area for the sun to come in and arch across the sky. So if I really need to, get the additional power that a tracking system would give me, my system's set up that I could add another 3 panels to each pole mount. So I got 2 pole mounts with 12 panels on each. I could add another 6 panels to the system.
They've done.
If I needed to.
I've read studies that show that them facing south is, and I know this sounds obvious, but most people wouldn't think about this. It's more important that they're facing the proper direction than the actual tilt is. In other words, if you were to tilt it, what are y'all, 36 degrees or something?
We're at 48.
Oh, so yeah. But they were saying that you only lose about. They did this study. I think it was in New York. They put them on a flat roof and then they tilted them 15 degrees and then they tilted them 30 degrees.
Mm-hmm.
And there was only there wasn't even a 10% difference between the flat panels and but if they oriented them away from south, it was really a lot worse.
Yeah, my poles are my azimuth is adjustable on the mount system that I have, so I can go from straight 90 up and down to you know straight up, straight laying flat on top. So we go from 48 in the summer to 22 in the winter.
Hmm.
So
That makes sense, being that far north.
yeah, so
Yeah.
you're almost straight up and down in the winter months, which makes it nice for the snow because the snow won't really build up on them.
Yeah, almost like you're not too far off the. Well, let's see, no, it would be a 12-12 pitch for 45 degrees. Yeah, so if you were doing it on your roof, these would be laying flatter than
Yeah.
what you'd want them to be. But of course, you could have always tilted them.
Well, you make up with it by putting more panels up, but I got these panels are come out of Mission Solar out of Texas, and they're 315 watts a panel.
Huh.
But by the time I got said and done with it, it was $37,000 is what my total investment and everything, all batteries and everything included, and construction costs, cost for me to rent the equipment to do the drilling the holes and everything like that. So we're
How
looking
deep
at.
did your? Do you know how deep your footings are? Is it 4 feet?
I'm 7.5 feet deep, and my holes are almost 4 foot in diameter.
Oh, good lord! You got some
Yeah.
torque going on the poles, don't you?
Well, the poles are 18 feet long, and I've got 11 feet sitting out of the ground. So,
It's
and then
still a lot better. I think the pole mounted panels are. I think they're still
yeah.
better than the roof mounted. I mean, just from the fact of maintenance. I mean, you could probably get to how far? What's the tallest panel out of the ground? Like the height
Oh,
off the ground?
I'm thinking I'm at about 19 feet, I think.
Hmm.
18, 19 feet.
That would be about as high as the east.
Yeah,
Yeah.
my array is about my arrays are about 15 by 16. The total, if you looked at the square footage is 50 times 16 would be the square footage of the array.
Huh. Uh-oh. I hope I didn't make Jason mad. Okay, well, let's see. I got.
So if we look at so we're going to put on the opposite side of that 10 by 10 door on the bottom box.
Over here.
Yeah, so if we can go inside.
Okay. So which boxes, which side are we going to be looking at?
The inside of the bottom box.
On this side?
No, go on the inside of it.
I know, but I'm saying which side, this side or this side? I have to.
Okay, on the as we're looking at it would be our west side. Yeah,
Over here.
yeah,
See, I have to do what you want me to do. I have to do like these section things. It makes it easier than trying to go through the walls and all that.
yeah.
So I have to face them a certain way. Get back up. What in the world? There we go. Oh, I already had. That's what it was. I already had some. I didn't realize I already had. Let me delete this one. Let me delete that one. Oh, I didn't realize I had active cut. Dadgummit. Today is weird. It's just everything's alright. This will make it easier. Alright. Now.
So we're going to put on that one, which will be, we're going to put a 10 by 10 opening in there.
To line up with this one?
Yeah.
Okay. So I think what I'm going to
do
is
I'm just going to... It'll just be an opening.
Okay. It'll just be an opening.
Right.
Okay. 10 by 10 opening.
Well, actually, it can be 10 by 10. And neither can that other door, because the box is only 9.5 feet tall. So.
Well, I know what you mean, though.
Yeah.
I mean, you mean the full height of the.
Yeah.
Because you. Or let's see. How much?
I'll need a header in there, so it's probably going to be better to say it's. They go width by height, right? So it'll be, let's go 10 is the width and 8. I got to give myself some room in there. Let's go 7. Because I got to get my room for the roll up.
Yeah, I think those canisters can get to like 16 inches.
Yeah.
Deep. Okay, and then this will just be.
Let's just go the full height of
yeah, and I know what that means.
9.5 by 10 or 10 by 9.5.
Yeah, because you're not going to try to put any ceiling material in there.
Oh, in that one.
Mm-hmm. Like you don't need a thickness of down from the door so you can put any ceiling. Okay.
Right.
So I'll know what that means. I know what the.
Yeah. Okay, let's see if I can. Don't really see the need to put any more openings in there. Let's see. You've got that opening. Let's come back to. Yeah.
The other side.
No, you're right on that side. Go. Let's put an opening on the bottom box, like a man door opening, but it'll just be an opening. And as we're looking at it on the left-hand side.
Like in this bay or in this?
Yeah, because we got a man door in there anyway, so we'll just call it an opening.
Okay, just kind of in the middle of that bay.
Yeah, because we got a man door. We'll open the man door and be able to go through that.
Yeah, they'll be lined up with each other. Yeah.
Right. So opening there. Let's put a man door. And stairs on the left-hand side of the upper box. I'm sorry, right-hand side of the upper box.
Let me do this. I'm going to turn the roof off. It might be easier than doing the section thing. Yeah. So the stairs, where would the stair go?
Okay, so we'll put an opening on the left-hand side. I'm sorry, right-hand side. I give my military right. So on the top box, on the right-hand side, put a man door opening. We don't need a door there.
Up here?
Yeah, and then we'll have to come up with stairs to get into that, up to that.
Maybe a straight run down the end of the wall.
Yeah. Yeah.
Because you don't want to block this, I guess.
Right. I don't know how much, how long that stairs would be for that. That's
It'd
8
probably
foot.
be about 14 feet long. Um, that's not too hard to figure out right quick. We'll just do a 4 foot. Let's see, what is that? That's Damn, I knew it was going to do that. Is that 7.5 inches? Yeah. And then I can just put this down. We'll just say it's close to that.
Yeah.
Am I on that? Yeah. And then we'll copy this down like 12 times and see where that gets us. How far off the floor? Yeah, I knew we weren't going to be all the way down. This is how I just rough out stairs until I start to actually make them. That's kind of how long. And then if you had a landing there, it'd come out 4 feet or 3 feet, whatever.
So how far does that come out?
That would come out about 14 feet, like I was thinking. Yeah. Well, you could put the door. You could have like a 4 foot by 4 foot landing and put the door in the corner.
Yeah.
So it wouldn't take up any space. Or if you got let's see, this top one would be the. Wait a minute. You know what just occurred to me? That is your landing. This is
Right.
This is the landing. So it wouldn't come out that far. I don't know why they do that. Something's weird here, but that's why I just roughed these out. Something is weird. Let's just make this go back 30 inches like that. So it'll be a little less than 14 feet. $13.7, something like that. You thinking?
Yeah, I'm trying to. So if we. Trying to think there's another way so it doesn't. If we broke it and swung the stairs the other way, so like you have a platform.
Oh, you mean like a U-shaped stair where you come down, then turn and come back?
Right.
Yeah, I mean you'd still take up about 7, probably 7 feet in width. both ways. Maybe an 8x8 square, 7x8 foot square. But
Because I gotta put a ladder into the other side as well, or stairs into the other side as well.
well, it might be better to have like a 4 foot mezzanine type thing that comes all the way across,
Yeah, I was thinking that too.
and then you'd have stairs that just come down one side, or maybe over here come down the end or something. Um,
Let's do that. Let's put a 4 foot mezzanine in there.
okay. And then which way would the stair come down?
Um,
Because then it would have to come down. Like what you'd have is like it would come over 48. Then this would be over here. Well, what the heck? Then you have this. This is what, 18 feet or something.
Yeah.
Like that. And I think this, I think this thing is leaning. Cause that's,
Yeah, it looks like it.
because I noticed that a while ago. Remember when I said something's weird looking?
Yeah.
Somehow this thing is leaning downhill, and of course that's what I get for doing it. Really trying to do it quickly. Oh,
Well, that's fine.
That's
We
actually
just gotta
funny
rub-
though. That's kind of weird looking, isn't it? Here, I'm gonna straighten it out real quick because that's just too much to bear right there. I'm not gonna get this. There we go. That's a little straighter. Now the only thing is, does this? What I was suspecting is, yeah. See that? That means what I'll do is, the reason I don't spend much time on this is because in this phase is because the stairs take a lot of time.
Well, we got the general idea.
Yeah, the stairs take a lot of time to draw. It's almost made it down there. So each riser would be 7 5/8 or whatever to make up for that little difference. So it wouldn't be that long. It would still be this long, because that wouldn't be there. Yeah, you'd still have that number of risers. They'd just be a little bit taller.
It chews up some space.
They really do. The stairs eat up a lot of space, and the only other way to do it would be to have the stairs come down and meet each other, and have a landing in the middle, and then have stairs come out. But that would take up space too.
Yeah.
Probably take up about the same amount of floor space. Because you can imagine if all this was
How much space would if I put a spiral in there?
oh, that would be nothing. I mean, what, 4 foot diameter?
Yeah.
You want to buy one of those?
Well, that's one option.
Yeah. Might be, you know what? It might be cheaper too, because by the time you build this mezzanine thing, well, let's see. I guess you'd still have the floor going across, connecting the doors, and then you'd have maybe on one end or the other have the circular stair.
Yeah. Or I could put this. Or I could put the stairs in the box. I'd have to cut a hole in the box to connect the two.
Let's see. You mean like a U-shaped stair? I guess you could do the stair over here, you probably wouldn't want to do it in. Well, you've got 10 feet to play with. You could get it. So you go
Well, like
up.
I'm saying, if I put the stairs like in the other box and had the mezzanine across between the two. So like if I put the stairs in the bottom box on the other side,
Yeah.
came up from inside there, and then put the mezzanine across.
Yeah. Then all this floor space will be freed up.
Yeah, I think let's do that. We'll put the stairs inside. We'll put the mezzanine there.
The other thing you could do is, let's see, you could let you could just cut this opening bigger.
Mm-hmm.
You know, that extra 3 or 4 feet, whatever, however wide you want them,
Right.
and just let a few of the treads come out. You know, where it would just be a straight run stair, which would be cheaper.
Right.
I'll kind of show it like that and see what you think.
Okay.
So basically, it'd almost be like as if this just went back 8 feet. That's really all. Or, well, that comes out too far, doesn't it?
Where does it put you in the box?
It should be up against the. It should have been up against the wall because I was up against it on the outside, so it should have. Let's see what it did. Yeah. See, there's our landing.
Okay.
I guess you got to cut the floor out. Let's see, the back of the, oh, that's the front of these. You know, the back of those containers have that weird thing in the back. You know, it's got a different floor.
Yeah, it's got a metal plate in the bottom of it.
Yeah. But this would be the end to do it on. Probably. If you're going to have to cut out the floor.
Yeah, but if I'm standing on the stairs here, am I have to bend down in order to come into there, or do I have to cut it? Oh, but we've opened up that.
Yeah, I mean, that's the only thing you'd have to cut out. You'd have to cut your headroom out. So it might be better just to put a... if you had I forgot exactly how see if they've got a circular stair. They're probably not drawn exactly. Oh, we should probably say spiral stair, shouldn't we?
Spiral stair.
What is this? There's probably not going to be one that's accurate. That's what I'm worried about. It'd be more like one of these on a pole type thing.
Yeah.
Right. Yeah. Well, I need to get. They have them that are really commercially looking. That's nowhere near what you'd want to build. They're real compact. Like, how would you? What would you actually have to be? Would you have to be taking anything up the stair?
So what I figured to do is put a beam in the center of the top box across to the other box, and support it with post, and so whatever I've got to put up from a storage standpoint, I can lift up with a chain fall or something.
This was what I was trying to figure out how the landing might work. Where
yeah, you have to rotate it some more.
Yeah.
There you go.
But see, they don't, and they're not that wide. The ones I've seen are only like 36 inches wide.
Mm-hmm.
Uh, the reason I was asking about what you'd be taking up there is because if it wasn't like big heavy stuff, you could get by. And it's like you're saying, if you had a hoist system,
Well, and I'm going to have a tractor that'll have forks on it, so I can also lift it up
yeah,
with that too. So
you can almost get by with a steep, like a stair. It's almost like a ladder.
well, yeah. Well, I got to make. I'm I'm getting up in years, so I got to make it fairly comfortable for me to get up.
No, but I mean, that you could make it where the treads weren't. The code would require
Yeah.
10-inch treads if it was a real stair. But you could make them to where the treads were really shallow, like 6 or 8 inches.
Mm-hmm.
But these aren't that bad. But to go up and down.
Have to look at pricing on a spiral stair, see what it costs.
Yeah, it might be more expensive. Might be cheaper just to get take a couple of 2x12s and and then put some channels in between them. Just put some flat treads on it. Not like a regular staircase, but something you just make up.
Okay, let's see. So we got the door opening there. Let's put a couple of openings, 4x4 openings in that top box.
Like windows.
Yeah, like windows. There'll be openings.
So would they be? Openings?
Yeah, like a window. Yeah.
Like in this.
In that general location and forward as well.
All the little lumps on the container make it hard to get it in a particular place. But I know what you mean, like one here and then one there.
Right.
Yeah, okay.
Okay, let's open up rotate to the other side. Okay. On the bottom box, I want to put a 15-foot wide opening centered up. Yep. And then on the top box.
Let me ask you something right quick about these openings.
Yeah.
So, you're not going to need much of a header up there. Probably only about a 6-inch. So do you want to make them as tall, or do you want to make them some kind of standard opening?
Well, they'll probably be about 7 foot tall.
Okay. That makes sense.
What I'll do is I'll just come in with some either square tubing or some angle, and then come in with columns on either side to support it.
And you won't need columns per se. You can just run the angle all the way around the opening.
Yeah. Okay.
Yeah, that's what I'm trying to say. You don't have any loads on. You don't have any load up here, so you could just use the angle all the way around.
Okay.
So.
And then let's see. And on the top box, we'll need a man door or a man opening by the walkway. And then we're gonna put a 15-foot opening in that box as well.
Oh, up here?
Yeah.
Is that going to be down to the floor?
What's that?
You're gonna have an opening down to the floor?
No, just in the box. There'll be a 15-foot opening in both boxes.
Right, but what size opening?
I'm not going to the full length of the floor. No. To the floor of that box. Yes. 15-foot wide.
So you'll have some kind of like temporary handrail to keep you from falling out the.
No. Oh, across it. Yes. We'll put a chain across it or something.
Okay, that's a good idea. So both of these will be like 15 by 7.
Yeah.
Okay.
What I'm basically going to do is I'm on that top one there. So that's going to be my storage box. That's going to go where we'll put feed and stuff like that up in there. That's where I'm gonna put probably an I-beam mounted in the box, and it'll be supported by steel mounted in the floor, and it'll have a chain fall on it, and I can pick up stuff and then slide it in there.
Will that go across here?
What's that?
Or the beam goes across
No,
here?
it won't go. It won't go across the full length. What it's going to do is kind of stick out far enough so that I can bring stuff up to it. I'll have it mounted and bolted to the floor for its support. So it's not going to stick out real far. As long as it stick out maybe.
Because if you ran one all the way across, you could have almost like a hoist system on a chain.
Well, I was thinking about that, but then I can't put any weight on those boxes, right? So.
Well, I mean, you could. What you'd do is you'd run the steel beam far enough to where you could put a post going down to this channel right here.
Mm-hmm.
You know.
Yeah, that's a possibility as well.
And then, I mean, it would hold, 600-800 pounds. I mean, you could put pretty much what you're going to hoist up there on it.
Yeah, what I was thinking is, because if I get tonners, there's 2,000 pounds for feed. You usually come in tonners. So, so that bag I would hoist up and put on a roller, like a rolling dolly, and I could roll it into position and have it up out of the way.
Yeah, and I was thinking too, for stuff like if this was I would be using this as a shop, and you get stuff that you work on, you can hoist it up off the floor, head height or whatever.
Yeah.
Let me meet my wife's calling me. Let me mute myself for a second.
Okay.
If you don't mind.
Not a problem.
Hey Karen, I'm doing a live feed here.
I didn't know you said anything.
Yeah, I'll feed her.
Okay, thanks.
Alright, bye. No. I'm back. Sorry about that.
Not a problem, Tony.
I just realized I'm supposed to feed the dog. My wife just reminded me to feed the dog.
I tell you what, I probably got enough there for you to work on.
Oh, I got plenty. Yeah, I got plenty because these openings are pretty. I mean, you're pretty sure about the openings, right? Because they're hard to change. They're not easy to do on this. I basically have to create an interference to cut all these. See all these waves?
Yep.
In the panels. To cut, it's literally easier to do it in real life than it is in the drawing. So I have to I have to draw like a box and have it interfere with them, and then tell it to intersect all the faces, and then I have to go in and delete all that stuff out. So,
Well, let me give you time to work on that. I
Yeah.
think you got enough in there to keep you busy for a while. Then, when you get to a point where we can look at it again, then we'll finish up with it. I think we got the windows where we need it. Turn it back around on the inside one more time. Looking at that wall. Got a big opening there.
just
big
realized
opening
too that
there.
these things won't be here either. That's a garage door track. Won't be there. Sorry, what were you saying?
Not a problem. I think where we got it right now, that's enough for you to digest on, and I'll give you whatever time you need to, and just give me an email or whatever whenever you're ready to sit down and talk again.
Yeah, that sounds good. I think it was a productive day. So,
Well, we got the general things in there. Give me some things to think about. I got to figure out what I want to do with those stairs.
yeah.
Because I do want to put a bathroom in there. I want to put a toilet and a shower in there, but I'm chewing up all my real estate. Because I was thinking about putting the bathroom in the, on that main floor, on the slab, and just building like a 10 by 10 bathroom.
Well, I mean, you could do it back here in the corner.
Yeah, but I got to put a trailer on that side too, and that trailer's going to use up some. I was hoping to put it in that corner where the stairs are at, but if I because the one thing we don't have on there right now, Tony, is and we didn't figure into the drawing, is I've got another 20-foot container that I want to mount at that back wall.
On the outside,
Yeah,
and you'd have an opening going into it.
yeah.
Okay.
So, but we can talk about that later. So we'll need to figure
Well, I
out.
mean, the door
and
going
what I-
into it would, let's see.
And what I figured to do is, because we're gonna have posts and stuff up there for that wall anyway. That we could take and because I was figuring we could probably throw a roof coming off of that wall, back wall, over the top of that box.
Just a shed roof coming off.
Yeah.
Yeah. Well, think about. I don't want to. Honestly, I don't want to put too many. I really don't want to work on it. If you don't mind, we need to really kind of figure out the floor plan. Maybe what I need to do is come up with like a 2-dimensional drawing of just the floor plan for each level, because I need to really figure all these openings are going to take a lot of time on these boxes.
The windows where you got the windows.
Yeah.
That looks good.
Yeah. But what I mean is all this area right here, I've got a big question mark in my mind on how this stair is going to work out, and because what's going to happen is when you put this box out here, you're going to have openings going into that, right? From in here.
If we have to, what I could do is put the box out there, and I can always access it from outside.
Okay. But the stair issue needs to be answered.
Yeah, so the mezzanine and the stairs, I know I need to do a track across. I know that's going to chew up 4 feet across, and I've got to put rails and all that stuff in there too, because I can't have just an open mezzanine or a walkway. It's going to have some kind of rail system on it. So, but we need to connect the boxes.
What if you, Okay, so you can't have a ladder system on one side and a stair on the other. Like one side's they're both gonna be equally accessed.
Right.
Okay.
Um,
The thing about it is this stair can go. You know, it can go. It can be worked out to where they go. It goes like that, and there's an opening right here in the wall.
mm-hmm.
You know that you walk in, and then the mezzanine can just be going straight across. So you don't
Yeah,
really need
because
this.
we could open that wall. We could open that up more if we wanted to.
Yeah, we don't really need this landing right here.
Right.
Cockeyed landing.
Go to the front of those boxes.
To the front of which ones? These?
Yeah.
Like this or this front?
Oh no, but the inside of them. Yeah. I was just thinking if we would have more room if we did. No, that's because that thing's. You said how many feet is that going to stick out?
Which one?
I mean, the spiral staircase.
Uh,
About 3 feet out.
this diameter, depending on what size, is typically 3 to 4 feet.
Okay.
And I can look that up. And then, but I don't. Well, okay, so that's a really skinny one. Okay, it just depends on how wide you want to make this. The part you're walking up. I've seen them where I'm a big guy. I've seen them where my butt's basically touch. They're so skinny that you couldn't. I almost had to turn sideways to get to get
Around
to get up. Or you can get big. They're basically whatever you want them to be. You know what I mean?
Okay. Well, let me look at that. I'll look at some different things because I was thinking of maybe sticking that up in the front of those boxes versus the back.
If I just measure this one, what is it? It's yeah. See, it's only like 5 feet across, which makes sense. That gives you about 30 inches for each for the width. But the thing is, you could tuck a bathroom in under here if you wanted to.
That's what I'm thinking too.
So if you move this 10-foot opening to this bay,
Yeah.
you might be able to slide the stair over a little bit and get your. Because you don't need a 36-inch shower.
Yeah, just whatever the standard shower and the toilet in there.
You only need 36 inches for a shower and then 30 inches for a toilet. I usually allow 6 feet, just to have enough room to get around. So, and then another 30 inches to 3 feet for the vanity, and then, coming out this way about 5 to 6 feet.
Okay.
So really 6 by 9,
Okay.
6 by 9, something like that.
Why don't you figure that in there?
Okay. And of course that would push I guess, you would want the bathroom enclosed though, wouldn't you?
Yeah.
So it really wouldn't work well.
The other option is to put the bathroom in the Conex box or the shipping container, which I can do. Yeah, we'll go ahead and plan on putting it in there.
On the end of this one.
One of the boxes, either in the top or the bottom. I'll probably put it in the top.
So you'd have plumbing hanging down. Probably.
Yeah, we'll just. Yeah.
Probably be better to put it in the bottom one, I think, wouldn't it?
Yeah.
Well, I guess I don't know. It depends on how you look at it. even though the drain line would have to still keep going down. That's all
Yeah.
you'd have going down. It's just the drain. You wouldn't have to roll the container over to get to the bottom side of it
Right.
to do the plumbing, which I've seen people try to do before.
Well, the thing is that I can pull the floor up
Yeah,
and
yeah.
then make the access holes to run the plumbing down the walls. So what they did is when I had them put the septic in, they ran an RB dump line for me so I could run that originally run it into the garage. So I'm going to tie the RB dump line and the toilet together on the same line running down to the septic system.
Where is that drain?
That drain right now is, if we look, it's on the north side. So what we said is that side that we were just looking at is the north side. So the shed side is the north side. And it's probably, right now it's probably about 20 yards north of that.
Out here somewhere?
It's down a little bit further out, yeah.
Yeah.
Out in that area.
Well, that's good. And it's got plenty of fall to wherever the...
Oh, yeah.
So you just got to get a drain from there to there.
Yeah.
How deep is it out here?
The line is buried down. I mean, it's got an uptick on it, but right now it's down, about 4 feet?
Oh, that's good. So you don't have to worry about the elevation of the bathroom versus that drain line.
Well, no, because where that line is right now is definitely got a fall.
See, in Tennessee, we only have to bury our septic, our field lines 2 feet. So sometimes it's hard to get enough slope. Somebody want to build a building way over here and try to connect it to that. There's not enough fall between the two distances to get.
So I already planned for this building. So on what would be the south side of it, we've already put in a big French drain. So we dug out dug it down 20 inches, and then put in drain pipe and drain rock. So for when the snow melts and stuff, I won't have it running into, because it slopes downhill toward the barn or toward the garage. So that French drain will keep water out of it. And plus, when the snow comes off of that roof, it'll slide out and hit that French drain, and it'll drain into that rock rather than pulling up and running into the barn.
Oh, my wife's texting me again. If you don't mind, I'll end it here, and then I'll do these openings and stuff.
Yeah, Tony, I appreciate it. I know you spent a lot of time with me today, so.
I forgot to go feed the dog. She's fussing at me.
Okay.
All right.
Well, take care.
Thanks, Roger. I appreciate it. Okay.
I appreciate it too.
Get all good information to help me along here.
Okay.